Here are the answers for the section 5-6 homework, starting on page 174. We're asked to simplify the expression. There is a fraction line in the expression, but the numerator itself has a fraction and the denominator has a fraction. This is called a complex fraction, when there are fractions within a fraction. We've learned two methods to solve this, and until we have some experience, we don't necessarily know which method is faster or easier. So in the homework, I'm going to just switch back and forth between the two methods so that you see both of them. One method is to remove the denominators of these fractions by multiplying all terms by the lowest common denominator. This denominator is 16, this denominator is 4. The lowest common denominator of a 16 and a 4 is the number 16. It's the LCM of 16 and 4. So I'm going to multiply all four parts by 16. So times 16, times 16, times 16, and times 16. Knowing ahead of time that I was going to do that, I left some space here and here to fill in those times 16s. So that's a suggestion when you're copying the question out of the book. Let's write down what we get. 1 times 16 is 16, plus this 16 and this 16 cross cancel, leaving 9. That's why we chose to times by 16 to begin with, so that that would happen. Now the fraction line. In the denominator, 1 times 16 is 16, then a minus, and this 4 and this 16 reduce, leaving a 4. 3 times 4 makes 12. We figured out that 3/4 times 16 makes 12. Hopefully you can see why timesing everything by the LCD was a helpful strategy. We still have our fraction line, but we no longer have fractions in the top or the bottom. Let's figure out this answer. 16 plus 9 is 25 in the top. 16 minus 12 is 4 in the bottom. The answer is 25 over 4. Now number 3, this is also a complex fraction. We have our fraction line, but there's another fraction in the bottom. I'm going to choose method 2 to solve this one, just so you get to see both methods in action. And then after trying it yourself, you can decide which one you like better. Method number 2 is to rewrite this kind of division bar using the old-fashioned elementary division symbol, that symbol there. So the problem looks like a minus 2 divided by 1 minus 4 over a squared. We should put these in parentheses to show that they were the numerator and the denominator. Once we've rewritten it in this form, we can now do some simplifying on this numerator piece and on this denominator piece. The numerator doesn't require any simplifying. It doesn't have any fractions in it. But this piece here does. This is a subtraction of fractions question. If it helps you to visualize 1 as a fraction, you can write over 1. That'll help you see the top and bottom. We've worked recently on how to subtract fractions. You need a common denominator. So this denominator is 1. This denominator is a squared. The lowest common denominator is a squared. We can turn this first one into a squared by timesing top and bottom by a squared. Let's rewrite this problem as a minus 2 divided by, and then put in our new version of this here. 1 times a squared is a squared, and then the minus 4. And this is over the common denominator of a squared. The next step is to take the division problem and write it using multiplication. Keep the first thing the same, change to times, and flip the second one upside down. Now that we have a multiplication problem, we would multiply the tops together and multiply the bottoms. But before we do that, let's look to see if there's any reducing. We can't reduce anything unless the parts are in factored form. And the a squared minus 4 factors. So let's leave the a minus 2 and leave the a squared and factor the a squared minus 4 as a plus 2 times a minus 2. Now we can cancel the a minus 2's. So the final result is a squared on top, a plus 2 on the bottom. So method number 2 took 1, 2, 3, 4, 5 steps to get to the answer. When we did question number 1 with method number 1, it seemed like we got to the answer faster. Now, was that only because question 1 didn't have any variables, or is that method actually faster? Let's try some more and see what we find out. Number 5, I'm going to go back to using method number 1. But before I do that, I need to take care of these negative exponents. This is equivalent to x plus x over y, all divided by 1 plus 1 over y. Now we can more easily see our complex fraction. Let's go with method number 1, where you multiply everything by the lowest common denominator. The lowest common denominator is a y. So we times this by y, times this by y, times this one by y, and times this one by y. This makes xy, plus this y and this y cancels away, leaving an x. Underneath the long fraction line, 1 times y is y. And over here, those cross out, leaving a plus 1. Let's see if anything will reduce if we factor the top. There's a GCF of x in both spots. So this is x times y plus 1. And that's divided by y plus 1. It looks like these will cross out. The final answer is x. So method number 1 looked like it worked pretty good. For number 7, I'm going to go back to doing method number 2, just so we can see what that looks like. Let's rewrite this division using the elementary school division symbol. We have a over b minus b over c divided by b over a minus c over b. The next thing we're going to do is actually simplify inside these parentheses by doing the subtracting fractions. To subtract fractions, you need to have a common denominator. If this is b and this is c, the lowest common denominator has both letters b and c. We can change this to bc by timesing by c, top and bottom. We can change this into bc by timesing by b, top and bottom. This part right here turns out to be AC minus B squared all over the common denominator BC. Now let's work on this piece in these parentheses. This is subtracting fractions. We need the same denominator. This is A and this is B. So the lowest common denominator is both letters, AB. Let's times by B and by B, and over here times by A and by A. In these parentheses, it turns out to be b squared minus ac all over the common denominator of ab. Next step, change that division into multiply. Keep the first fraction the same. Change to times and flip this fraction upside down. Now that we have multiplying, we multiply the tops together and multiply the bottoms together. But before we do that, let's try to cancel things. There's a b in the bottom and a b in the top. Those cancel away, leaving a whole number of 1. There's a c in the bottom, but there's not a single c in the top. We cannot cancel the c. There's a ac minus b squared in the top, and in the bottom there's a b squared minus ac. We have had this situation before. These don't match each other exactly, but they are inverses of each other. They cancel away, leaving negative 1. So what we have left is negative 1, a in the top, and the letter c in the bottom. We could write this as negative a over c. So that was method number 2, where you change this fraction line into the old-fashioned division symbol, and then you simplify your numerator and your denominator. I don't know, that was only 4 questions, but I'm leaning towards method 1 as my favorite. You can use whichever method that you are better at. For the review assignment, we're going back to where we were adding and subtracting fractions. You have to have a common denominator. So let's find the lowest common denominator. If this is 2 and this is 4, you need to have a 4. And this has a squared and this has an a, so you also have to have a squared. We can turn this into 4a squared by timesing by 2a squared, and in the top. This is already 4a squared, so we don't need to times it by anything. We can turn this into 4a squared by timesing by 4a, and in the top. All right, let's rewrite all these fractions. 1 times 2a squared is 2a squared, all over our denominator of 4a squared. Now a plus sign. We have 3 over 4a squared. Now a minus sign. 1 times 4a is 4a over the 4a squared. Notice that all of them have a 4a squared, a common denominator. So let's combine the tops and write it over the common denominator. We have 2a squared in the top. There's also a minus 4a in the top, and there's also a positive 3 in the top. And this is all over 4a squared. Number 15 is an adding problem with fractions. We have to have a common denominator. If we have a 2 and a 3, what is the LCM? It's a 6. We can turn this into 6 by timesing by 3, and in the top times by 3. Notice how I put it in parentheses, so I times them both by 3. We could turn this into 6 by timesing by 2, and in the top times by 2. Again, I'm putting parentheses around it to remember to times both things by 2. Let's rewrite. We have 3 times x and 3 times negative 1, all over the denominator of 6. Then we have 2 times x and 2 times the minus 4, all over the denominator of 6. Because they have the same denominator, combine the numerators and write it over the denominator. 3x plus 2x is 5x. Negative 3 plus negative 8 is negative 11. That's all over 6. Number 17 is adding and subtracting fractions. We have to have a common denominator. Let's figure out what it is. This is 3, this is 4, this is 2. What's the lowest number you can think of that's a multiple of 3 and 4 and 2? That's 12. This has one n, this has one n, but this has a pair of n's. We have to have n squared in our LCD. You can't use just a single n, because that last one has more than just a single n. All right, let's turn all of these into 12n squared. We have to times by 4n. And in the top, times by 4n. This one here we have to times by 3n. And in the top, times by 3n. This one here we need to times by 6. And in the top. Let's rewrite this using our new denominator. 4n times 2n is 8n squared. 4n times 1 is positive 4n. Now we have a minus sign. Make sure you distribute that negative with that number that you're timesing to these. So think of it as negative 3n times 2. That makes negative 6n. Think of it as negative 3n times negative 3n. That's positive 9n squared. Okay, this last one has a plus sign, so we're thinking of it as a positive 6 being times to 1. And that makes positive 6. And that's all over our common denominator of 12n squared. Now let's simplify the top by combining like terms. 8n squared plus 9n squared is 17n squared. 4n take away 6n is negative 2n. And there's a plus 6. And that's all over the denominator, 12n squared. Number 19, we have something with a negative exponent. So our first step is to rewrite that. 1 over x, and now it has a positive 1 exponent. But you don't have to write exponents when they're just positive 1. We can now easily see that this is an adding fractions problem. If you don't recognize the first one as a fraction, put a 1 under it. That'll help you see the top and the bottom. What is our lowest common denominator? It's an x. We can make the first one have an x in the bottom if we times by x, and in the top. This one already has x, so we don't need to times by anything. 1 times x is x, and then we're adding 1, and that goes over the common denominator of x. Number 23 is subtracting fractions. We have to figure out the lowest common denominator. This has x plus 1. This has 3x. The lowest common denominator has to have both of those factors. So we can make the first one be that denominator if we times it by 3x, and in the top. We can make this have that denominator if we times it by x plus 1, and in the top. Let's rewrite our fractions. 3 times 3x is 9x. Now we're subtracting. Make sure you think of that subtraction as going along with that 2. Think of it as negative 2. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. That's all over our common denominator. Next, combine like terms in the top. 9x take away 2x is 7x. And that's all over our common denominator. On page 169, we were simplifying fractions. This is where we were multiplying and dividing fractions. Before we do any multiplying in the middle, let's fix this negative exponent. So let's write the first one exactly the same as it is. Keep the timesing, and flip that second fraction upside down. Before we actually multiply anything, let's look for reducing. 24 and 18 both divide by 6, leaving 4 and 3. The m to the third in the bottom cancels 3 of these away, leaving a new exponent of 3. The n in the top cancels 1 of these away, leaving a new exponent of 3. In the top we have 4 times 2, which is 8, and m to the third times another m, which is m to the fourth. In the bottom we have 3 times 9, which is 27, and n to the third. Number 16. Before we multiply, let's try to reduce stuff. But you can't reduce anything unless they're in factored form. In the x squared minus 9 factors as x plus 3 times x minus 3. The 4x plus 12 factors as 4 times x plus 3. The second fraction doesn't look like anything factors. Now let's try to reduce things. X plus 3 cancels x plus 3, leaving a whole number of 1. X minus 3 cancels x minus 3, leaving a 1. How about 4 and 6? Can you reduce those? They both divide by 2. 4 divides by 2, leaving 2, and 6 divides by 2, leaving 3. In the top we have 1 times 3, and in the bottom it looks like there's just a 2 left over. Number 24, same thing. We want to multiply and divide, but you can't have polynomials. You have to have factored form to reduce things. And the other thing is, you also don't want to leave the divide in there. We need to write it as timesing and flip over that second fraction. So I'm going to rewrite the whole thing. I'm going to do the factoring as well as changing to timesing and flipping that one upside down. So starting right here, we can factor out a 5c. leaving c minus 1. Down in the bottom, leave the 4a cubed. In this spot here, this trinomial factors as c minus 10 times c plus 1. In the bottom, we can factor out a 4. 4 times c minus 10. Now change to times. We're going to flip this one upside down, so the letter a ends up in top. This ends up in the bottom, but it factors. I'm going to factor it right now. This is 2 times 1 minus c squared. But 1 minus c squared is a difference of squares, and it factors more. So I'm going to write this as 2 times 1 plus c times 1 minus c. So let me take that out of there and think of this form as being the number under the bar. Now that everything has been factored, let's look for things that cancel. In the top, there's a 5. That won't cancel with a 4, or with a 4, or with a 2. So we cannot reduce our numerical coefficient. In the top, there's a letter C. But when you look all the way across the bottom, there are no C's that are their own factors. So we cannot cancel the C. What about C minus 1? Is there a C minus 1 in the bottom? There's not, but there is a 1 minus C, which is the inverse. We've had this a few times. You can reduce these, but it doesn't make 1. It reduces and makes a negative 1. Okay, how about C minus 10? Yup, that cancels away. How about C plus 1? Is there a C plus 1 in the bottom? Yes, there is. 1 plus C is the same thing as C plus 1. What about this A? Are there any A's in the bottom you can reduce with it? Yep, we have some A's out here. So this A cancels one of these away, making a new exponent of 2. I think that's all the reducing. In the top, we have 5 times negative 1, which is negative 5. And there's also a letter C. In the bottom, we have 4 times 4, which is 16, times 2, which is 32. There's an a squared left over. But as I look across, I don't see any more letters left in the bottom. So here's our final answer. On page 167, we were writing rational expressions, taking expressions and writing them with a numerator and denominator. I see that we have negative exponents, so let's take reciprocals. The x minus 1 to the negative 3 will move into the bottom and now have a positive 3 exponent. The y minus x to the negative 5 will move into the top and now have a positive exponent. Do these match each other where we can do some reducing? They don't, but they are inverses of each other, which we've had several times. So we can do some reducing, but we're left with negative 1, not positive 1, when we cancel them. So we can use all 3 of these to cancel away 3 of these, leaving an exponent of 2, but you have to realize when you canceled those things, it created a negative 1, not a positive 1. So our answer is negative 1 times y minus x squared. On page 164, we're also writing a rational expression. So this one is 1.3 times y. To write a rational expression, we need to write 1.3 in its fraction form so that there's a numerator and denominator. This is the mixed number 1 and 3/10. And the mixed number 1 and 3/10 is 13/10. So this is 13/10 times y, or 13y all over 10. Now we're asked to give any restricted values of the variables. That will only happen if the variable is in the denominator. This one does not have a variable in the denominator. It just has 10 there, so there are no restricted values. The letter y can be any real number. Number 8, the part with the negative exponent, let's move into the bottom of a fraction. It now has a positive 1 exponent, which you don't need to show. Here is our answer. Now, are there any restrictions? Are there any numbers that t could not equal? There is a variable in the bottom, so what we know is that we don't want the denominator to equal 0. Here's what you write. T minus 2 cannot equal 0. Now solve this for t. We find out t cannot equal 2. That's called a restricted value. T can be any number except 2.